Hello, welcome to Maths with Jay. So we've got a first order differential equation here, where we're going to be able to write the left-hand side as the derivative of a product of y and a function of x. And the method that was going to work here is the integrating factor method. But before we can use that, we need to make sure that the coefficient of dy by dx is 1. In other words, we need to divide through the whole equation by sine x. So that's going to give us dy by dx. So that's the important bit. And then we are going to divide the next term by sine x. So we'll put the sine x under the cos x. And remember, you need to divide the other side by sine x as well. So dividing sine x by sine x will give us 1. So that will just give us sine 2x. So now that's in the right kind of format. And remember that we want to write the left-hand side as the derivative of a product of y and a function of x. And we'll be able to do this if we multiply the whole equation through by the integrating factor. So let's write down the integrating factor. So this is going to be e to the power of the integral of, and now what we want here is the coefficient of y. So that's going to be minus cos x over sine x. And that's going to be, well, the integral of 1 over sine x is log of sine x, isn't it? And we've got the derivative of sine x there being cos x. So that means we're going to have e to the power of minus log sine x. And that's equal to e to the log of sine x to the minus 1. So e and log, well, those are inverse functions of each other, opposites, so we're just going to have 1 over sine x. So that means that we want to multiply our equation through by 1 over sine x, or if you prefer, cosec x. So let's do that. So we've got 1 over sine x times dy by dx minus y cos x, and multiplying the sine by sine, we get sine squared x, and then that's equal to sine 2x over sine x. So now we can see that we can write the left-hand side as derivative of a product. So long as you've worked out the integrating factor correctly, that will always work at this stage. So the left-hand side, we've got the product of y and 1 over sine x. So we could write the 1 over sine x as sine x as the denominator there. And then we can simplify the right-hand side, because sine 2x is 2 sine x cos x, and divide that by sine x. So we've got sine x cancelling with a sine x there. So that's equal to 2 cos x. So now all we need to do is to integrate both sides with respect to x. So the left-hand side is very simple, because we'll have y over sine x. And then integrating 2 cos x will give us 2 sine x plus c, of course. Oh, I've left the x out. 2 sine x plus c. And we have been asked to give the answer in the form y is a function of x. So that means that all we need to do is to multiply across by sine x. So we've got sine x multiplying 2 sine x, and remember to leave the plus c inside the bracket. So you could leave the answer like that, or you may like to write it as 2 sine squared x plus c times sine x. And then you may like to check your answer. So let's start by differentiating what we think y is. So dy by dx is going to be 2 times 2, so that's 4 sine x cos x. And then differentiating sine x will be cos x, so c times cos x. And then what we'll do is write down what the original left-hand side was. So that was sine x dy by dx minus y cos x, and we'll substitute in the dy by dx and the y, and we should end up with the original right-hand side. So sine x to start with, and then we're multiplying our dy by dx, so that's 4 sine x cos x plus c cos x. So that's sine x times dy by dx. And then we'll have minus y times cos x, so minus 2 sine squared x plus c sine x, and that's going to multiply cos x. So what have we got now? And also thinking about what we want to get. We want to get sine 2x, don't we? Or even sine 2x multiplying sine x for the original equation. Well, we've got a sine x in everything, haven't we? And we've actually got a sine x times c times cos x in both of them, haven't we? So we can actually cancel those to start with, so that what we're left with is, let's just take a sine x outside a bracket and see what we've got. So from the first one we've got 4 sine x cos x, but the other one, I'm writing this now with a sine x outside, so that's going to be minus 2 sine x cos x. So that leaves us with sine x times 2 sine x cos x. And that is in fact sine 2x, isn't it? So sine x, sine 2x, and therefore we must have got the right answer.